Okay, I kind of agree with that.
I'm recording. Okay, here we go. Intervals of increase, decrease, and constant. Okay? A function increases over an open interval of its domain if a graph rises from left to right on the interval. Okay? If the graph is rising from left to right, so grab your green highlighter. As I trace this graph from left to right, this graph is going up until I get here to this maximum point. Okay? Likewise, a function decreases over an open interval of its domain if a graph falls from left to right on the interval. Okay, so from left to right, this graph opens up. So from left to right, it is falling until I get to this minimum. Okay, and then finally, a function is constant over an open interval of its domain if its graph is flat on the interval. Okay? Right there, that is just a horizontal line. Okay, so we are tracing our graph or looking at our graph and reading it from left to right. Is it going up? Is it going down? Or is it staying flat? Okay? Now, a lifeline alert. Okay? When we write these intervals, please understand that we are going to refer to the x values where it increases, decreases, or remains constant. We are looking at our y values. Is it going up or down? But we are going to write the interval from left to right. So from here to this point on the x-axis, it's rising or it's falling, okay? So we are going to write them according to our x values, okay? Flip it over, please. So we read a graph in math from left to right the same way that we read a book, okay? Now, on the left side of the graph, it's coming or approaching negative infinity, okay? The further I move to the left, that graph is going to negative infinity, and the further I move to the right, my graph goes to positive infinity. Okay? Now, the same thing happens with my y values, but I'm not going to mark my y values here because I am writing it according to my x's. Okay? So, very quickly, okay, if I were you, I would just keep your highlighter colors open so it's much easier to flip between them. Okay? From left to right, this graph is increasing on the interval -5 to 2. I'm highlighting the x-axis. To me, that makes it a little bit easier. And then it is constant from -2 until I get to 1. Then it is increasing again from 1 to 3. And then the graph decreases from 1 to 5. Okay? So I am going to say that my graph is increasing. This graph is going up from here to here on my graph. Okay, and that happens to be right here on this interval, -5 to -2. You don't have to worry about putting a bracket or parentheses. With intervals of increase, decrease, just stick with parentheses, okay? All right, now, then it is constant from -2 until I get to 1. So from -2 to +1, it is flat, okay? And then it rises again. It increases again from 1 to 3. When I have more than one interval that does the same thing, I'm going to put this little U in between them. That U stands for union, and union means joining together, okay? So I'm joining these intervals that are both increasing together. All right, so I've done these 3 intervals. So the last one is this interval of decrease, and it decreases from 3 to 5. Why did I not say to infinity or coming from -infinity here? Because it stops. That was a solid point, right? That is not an arrow to tell me it keeps going, okay? So make sure you pay attention to the little things like that on our graphs. Do you see the difference between these beginning and ending points on this graph versus the graph down at the bottom? Yes? What do you notice here?
It's not a straight line.
It's got arrows, okay? Now, so that means I need to write in on one side -infinity and on the other side +infinity. Okay? So, right here, this graph is falling. There's an arrow. So from left to right, it's falling until I get right here. Okay, this is where it turns and then it starts increasing until I get here. Then it's what? Constant. It's flat until I get here. And then what does it do? It decreases again, and notice it's following that arrow, okay? So watch what I do here, okay? I understand I've color-coded this already along the graph, but what I want to say, or what I want to do, is I am going to color code my x-axis according to what the graph is doing. Because I have an arrow going backwards, that means that that graph is still going to be following that same pattern. Then, from here to here, it was rising. From here to here, it was flat. And then starting here at 5, and for the rest of my graph, it continues falling. Okay? Do y'all see what I did? I just want to make sure that we indicate the changes in my intervals right here, okay? Those changes happen at the x values. So, as I read my graph from left to right, what is it doing first? It's decreasing. So So as I read from left to right, it is falling from negative infinity until I get to 0. A lot of people will be tempted to say -2, but am I writing it according to my y values? No, we use our x's, okay? Then from 0 to 2, what is it doing? Increasing. So from 0 to 2, it's increasing. What about from 2 to 5? It's constant. And then starting at 5, for the rest of my graph, what is it doing? Decreasing, okay? So starting at 5, for the rest of my graph, as I move to positive infinity, it is going to be falling. Another common mistake here is that people want to put negative infinity right here because it's going down. Don't do that. That is what's happening to the y values. They're going down, okay? But that's happening as I move to the right, okay? All right, now let's talk about domain and range, because domain and range is what we talked about the last 2 days, okay? The domain is any x values that are covered on my graph. Now, as I trace this graph from left to right, okay, there's an arrow indicating that it's continuing on, right? So as I read my graph from left to right, is there any break in my graph? Is there any hole on my graph or anywhere I have to pick up my pencil and move elsewhere to continue my graph? No. So what that means, since I have arrows on both ends and there's no holes or anything funny happening here, that means that my domain is all real numbers. It goes from negative infinity to positive infinity. You can say it like this. You can use that fancy R we talked about yesterday. Or you could say that your x values fall between negative infinity and positive infinity. Any one of those 3 notations is totally fine. Okay? All right, now how do I read the range?
Just say, well, the range is the y-intercept, so.
The range is the y values.
Y-values.
Yep.
So see where the highest it can go is the lowest it goes.
Okay, but if I'm reading from left to right for my domain, that's least to greatest, right? What's least to greatest on your y-axis?
-2.
Don't worry about that. Bottom to top is what I'm looking for, okay? Remember, domain, we read left to right. And the range, we're going to read bottom to top. Now, I don't see anything right here, but I've got this arrow. What does that arrow tell me?
Infinitely down.
It keeps going down, okay? So this graph, I've got a negative infinity right here. And everywhere I go, remember, there's no holes in this graph, and there's no, like, split where I have to pick up my pencil and go somewhere else to keep drawing it. All of these y values are covered. And then I've also got this arrow right here, which tells me that it's going to continue moving up. So is there any y value that's not covered? No. I can say my range goes from negative infinity to positive infinity. I could say all real numbers. Remember, range is our y values, so we could say that our y values fall between negative and positive infinity, which basically means it goes on and on and on. Okay, I'm going to ask you one more thing about this graph, okay? Would you say that this graph is discrete or continuous? It is continuous. What makes something discrete? It like stop, start, starts, like it's individual little things, okay? All right, flip it over, please. Okay, and we're going to look very quickly at all of these pictures. Now, I want you to notice that we have exponential functions, we have linear functions, and we have quadratic functions. Okay? These are the three types of functions we have talked about this year. So you have to be able to tell us whether it is increasing or decreasing for any one of those three types of functions, okay? All right, so right here, my graph got cut off on number 1. So I would like for you to draw arrows right there on the ends of that graph. Okay? Now I want you to take your handy dandy pointer finger and we are going to trace this graph from left to right. As I move to the right, what is my function doing?
Being consistent.
It's what?
Being consistent.
It's decreasing, right? Now, I need you to remember that with an exponential function, yes, it is flattening out, yes? But that does not necessarily mean that that is constant, because there is an asymptote there, and it can get closer and closer and closer to that asymptote, but it's not actually ever going to touch it. So this entire function is decreasing. It falls from negative infinity to positive infinity. That means there is no interval of increase and no constant interval. This whole graph falls from left to right. Okay? All right, number 2 is a linear function. This graph from left to right is doing what? It's increasing. It is increasing over the entire function. Does a line change directions at any point? No, right? So my line is either going to be increasing the whole time or decreasing the whole time. It's never going to change. Okay? Now, this quadratic function, as I'm tracing this, do you notice how it turns? Yes? And where does it turn at? What do I call this point?
Vertex.
It's the vertex. And through the vertex, we have this thing called an axis of symmetry. Okay? My graph is falling from left to right until right here. And then it turns and does what? Increases for the rest of the function. So I have 2 different types of intervals here. Okay? It is decreasing from negative infinity until I get to what value?
-3.
Until I get to 2. Remember, we are writing this according to our x values, hence why I marked the x-axis. And then at 2, it turns and it starts increasing, and it increases forevermore. So to infinity. Is there any flat interval here? No. There will never be a flat interval for a quadratic function. Okay? All right. As I am tracing graph number 4, okay, I need to see eyeballs. Okay? This graph is going up, then it's going down. The change happens at this vertex, and the x value of that vertex, again, happens to be at 2. So this graph is rising, and then it is falling. Okay. Super common mistake. Don't do this, okay? People often want to say that it is increasing from 2 to negative infinity. As I move to the right, am I going to negative infinity, my x values? It's going to positive infinity. Negative infinity to positive infinity, okay? So from 2, sorry, I wrote that wrong. It is increasing from negative infinity until I get to 2. And it is decreasing from 2 to positive infinity. And there is no flat interval right here. Okay? Look at number 5. What would you say about this line? The whole thing is decreasing. So from left to right, from negative infinity to positive infinity, the whole thing is decreasing. Okay, I'm actually going to come up here and I'm going to highlight this one also, and I'm going to highlight this one being green on the x-axis. Okay? All right, on number 6, oh, I need to write none and none. Don't leave them blank because that tells me you didn't answer it, okay? All right, number 6 is an exponential function again, okay? My asymptote is actually drawn in. What's happening from left to right here?
It's increasing.
The whole thing is increasing. It never turns and falls, and there is no flat part of the exponential. The entire graph from left to right is increasing. Okay, number 7 is a line. The whole thing, friends, is constant because it is flat. So from negative infinity to positive infinity, the whole thing is constant. What would you say, friends, about number 8? The whole thing is falling. So the whole graph is decreasing from negative infinity to positive infinity. It never turns to rise, and there is no flat part of my graph. Which 2 of these functions would you say have some similarities? Do what?
8 and 1.
Okay, 8 and 1. Okay, yes, so I just mean like what function families?
Number 4. And number
3,
All right, what would you, okay,
5, 1, 8.
what do linear functions and exponential functions have in common as far as my intervals of increase, decrease, or constant?
They're both infinitely going towards the direction that they whether positive or negative.
That's perfect. Okay, he said they're all going infinitely towards whatever direction. A line is all in. It's either all increasing, all decreasing, or all constant. Yes? An exponential function is either going to be all increasing or all decreasing. What is different about my quadratics? They turn. Okay? They are split and they have an interval of increase and decrease. And what value does it change? What value am I using to mark the change? The x value. Okay? Use the x values to write your intervals. Okay? And I'm going to put a star by that. Use the x values to write your intervals. Okay? Okay. Right here. Okay? It says, consider the tables. What type of function does each represent? And then determine the intervals of increase, decrease, or constant. Okay. Let's take a look at this. As I move forward 1 unit, what am I doing over and over and over again? Do you see a pattern with your y values? You're adding 4 over and over and over again. If you are adding the same thing over and over again, that makes this a linear function. And this linear function, because we're going up, is increasing from negative infinity to positive infinity. Okay? All right. What do I do to get from 0 to negative 1? You subtract 1. What do I do to get from negative 1 back to 0? You add 1. Am I doing the same thing over and over again this time? Nope. All right, how do I get from 0 to 3? Add 3 and add 5. Okay, I do not see a pattern. Okay, but right here, this is what I call the first difference. Okay? This is what I call the first difference, which is what happened right here. The very first time I started trying to find a pattern, I saw the pattern. Okay? Now, right here, I'm going to calculate the second difference. What do I do to get from negative 1 to 1? You add 2. What do I do to get from 1 to 3? You add 2. And what did I do to get from 3 to 5? You added 2. What do you notice there? Okay? Right here, the second difference is where I found my pattern. If the second difference is where you find your pattern, that makes this a quadratic function. And what do we know about quadratics? They turn. So there is an interval of increase and there is an interval of decrease. Do you see right here in your table, you've got this 2, negative 1? Do you see how on one side of it, it was going down? And then it turned and went up? Where that change happens is where the change happens or where the graph turns. So I'm going to use my x coordinate. Okay? Before it was falling, and after it rises. So it increases from 2 to infinity, and it decreases from negative infinity to 2. Yes?
Are we going to be able to use decimals for this?
Yeah.
So we just like put decimals on the board and then solve it like a normal graph equation?
Well, I'll have to teach y'all how to put a table into Desmos so you can see the pattern of the behavior. But yeah. Okay. All right, now, what do you notice is happening here on this last one?
It seems to
You are multiplying by 3 over and over again, okay? So that makes this an exponential function. Specifically, this is an exponential
increasing.
growth function because my common ratio is 3. Y'all remember those geometric sequences? Okay? So this graph is going to be increasing the whole time. It increases from negative infinity to positive infinity. Okay, I love these 2 questions right here. These are milestone type questions, okay? If you have a parabola, which is a what type of function? Quadratic, okay? Which is my U-shaped graph. If I have a quadratic with a positive leading coefficient, what does that mean about how my graph opens? It opens up. So it's going to look like this. And it tells me that I have a vertex at the ordered pair 2, -5. I am asked for my interval of increase. I am looking at my little sketch and I see that it increases after the vertex. What value do I use to write my intervals? Huh? What did we write at the top of our paper a minute ago? We use our x value. So my x value here is 2. So from 2 to infinity, it rises. Okay? All right, this one. If you have a parabola with a negative leading coefficient, what does that tell me about my graph?
Opens down.
It opens down, okay? And it has a vertex at the ordered pair, -7, +4. What would be the interval of decrease? This one decreases after the vertex. What value do I use to write that?
Negative infinity. Or no, sorry, -7.
-7 to positive infinity. Okay?
So even if it's going down or up, it's always going to be positive.
Yep, because I'm moving left to right. Okay? All right. What do you notice about all of the linear functions? They either always rise, always fall, or they're always constant. What do you know about exponential functions? They are either going to always what? They're either going to always increase or always decrease. And what do we notice about the quadratic functions? There is an interval of increase and an interval of decrease for every single one, because there is a turning point at the vertex. Okay? All right. So I need for you to listen to me very carefully. You have an assignment, and it is going to count as a minor grade. It includes, actually, very quickly, there is going to be a mini. I'm going to have you do the mini real quick. Okay, we're going to start there. Okay?